This is Hallicrafters Rehabs, and I'm Albert, and thank you for the new subscribers. Welcome back. I've been busy. It's Friday. Monday, I sort of abruptly ended the video. It was not going well that day. The mower quit. These are my high-powered reading glasses. They cracked and broke. Ever done that with a component? Right at the very tip. Clipped that while I was trying to remove a jumper off the switch. And various and sundry other things. It was not good. Things were not going well Monday. But my time with my father was very good. My amateur gerontology tip for the day is use it or lose it. And that's especially true for someone who's 100 years old, because the rate at which you lose muscle mass just keeps on going more and more and more exponentially as you get that age, which is why you see people in wheelchairs and things like that. And he was a track and field athlete in college, so he's benefiting today from the fact that he's still able to use his walker most of the time. He did fall a couple times before I got there. He just slides down the wall. He doesn't really hurt himself, but still, he was able to use his walker the entire time. I really want him to take every step, because every step he takes is potentially another step that he can take later because of the use it or lose it principle. So it was a good visit. I've been busy since yesterday. A sip of coffee. I did get the switch in, and the leads connected. Yay! And this is my third iteration on getting the capacitors in the B+. These are a little bit heftier capacitors, but what was more important to me is the leads were better configured to get this in here. So you can put a 33 instead of a 22, no sweat, anytime you want to. And this is actually 100 instead of a 68. So the total is about, 166, 170 versus what it would be otherwise is about 100. If anything, it'll be a quieter set just on that basis alone. So unavoidably you're recapping whether you want to or not as you progress through this. I just sent an email to a friend on the Hallicrafters group, David, and I told him that if there were an alien from another planet were to ever land on Earth and watch people smoke and then wonder about it, please send them to here and I'll explain to them what it does to radios, and they probably won't want to start smoking, because every single thing has to be cleaned carefully. Gum is everywhere. In this volume switch over here, cleaned it multiple times with this HFE and the deoxit and so forth. By the way, I did get the mower working. I either had a bad batch of fuel or there was water in it. That was a lot of fun, getting the water. I could have put that on the video, getting gasoline all over everywhere, but June put that to work on killing a tree stump that she wanted dead. Anyway, so there's a lot of cleaning that has to be done in here, and I'm just sort of marching my way. This is not finished configured. Another thing rather interesting, I always look for good recycled material, and the flat screen at my father's house died, and it used these kind of connectors because the HDMI failed on it, so we were using this. Well, this is nicely shielded flexible cable, so I'm using it for the phono lead from the phono plug to the switch. So it's good stuff. It's worth hanging on to. A good shielded cable that's flexible and easy to use instead of RG stuff that is really designed for outside. Makes it a whole lot easier wiring things up. Try to keep it away from tubes and things, but the heat's going to be going that way, so I really don't see it having any effect on the lifetime of the cable. So that's where I'm at right now. This is in. I'm going to go through these switches one more time, get them properly connected up again. This is standby receive. This is noise limiter, and this is AVC. Now, all of the capacitors, the mica capacitors especially, I'm checking for leakage. I use, this is a Mr. Carlson's Lab DC leakage tester, and it's best if it's kept off, although if it's not connected it's not doing anything. And this is the forecasting one, which is also a mic. It has mica and forecasting. I could put a forecasting under the end. It has electrolytic, mica, forecasting, and then poly setting for it. And this is the, I go ugly quick as opposed to fancy good, slow, because I've been using this constantly. And just pulling one of these out randomly again. I've done this, shown this to you, but I think I've got a mica here. I'll give you an idea. I may have pulled a mica. Well, thus far, I think my micas have been okay in this set, which is a great news. So, first of all, how you read this, same as a resistor. Everybody remembers Bad Boys. Rile our young girls. See, I'm a pastor. Rile our young girls, but Violet is graceful willingly. So that's how you remember. This is a 2, that's red, EB red. Yellow is the number of positions past the decimal point. And actually, this was probably got it says silver, which is probably a 20% configuration. So, I mean, tolerance. So, if I were to test this, and so what we're seeing is this light, this LED light, and it's staying bright. The light should go out, but it's not, because it's still passing current, and it shouldn't be passing DC current at all. It should be passing zero current. Now, it's dimmed a little bit, but it's never ever going to dim all the way, because this is turning into a resistor. I've got a good one over here. Then this one is the same value, 222.02. So we'll just go discharge off. Okay. I'm not concerned about getting shocked by a capacitor that's that leaky. All right. All right. That's how fast it went. This is a good one. It's charging up. As long as there's current and it's charging up, then it's a good capacitor. Now here's an electrolytic over here. 1,000 microfarad, 50 volt. I don't know what that's doing over here. So we're going to do red here. I don't think it makes any difference on the polarity for this thing. So, all right. So now it's charging up. 1,000 microfarad is a lot. It's on the electrolytic setting. Is this? There we go. It's just now beginning to dim. I should have picked a lower thing. We'll speed this tape up here. I wonder if I want to do it the other way around. Yeah, it didn't make any difference. Well, we'll leave that for a while. But I would encourage you to get this. The design for this thing is on Mr. Carlson's Patreon site, and it's just loaded with all kinds of good stuff. This is probably the best money thing I've built off of that, not putting in bad capacitors and keeping the good ones, because you do have good ones. And $2 a month is pretty cheap just to have access to that information. His latest video on Patreon is probably the most interesting one I've seen on reducing hum in radios and amplifiers. So that's worth $2 a month just to listen to that one video. So I highly recommend it. Old fogies like me had to be introduced to what Patreon was. I had no idea for a while. So anyway, man, maybe I don't ever test it in electrolytic, so that may not be, I may not be the best of, I may not even have it wired up properly for electrolytic. At any rate, the mica works good. It's still discharging. I should really pick up. This one is 10 microfarad. Okay, it did discharge. Maybe you have to wait a while for, we don't have time for 1,000 microfarads. Why'd I pick that? This one's 10. This is the one that came out of the set. Mr. Carlson's latest Patreon video talked about that this was the cathode bypass on the output tube capacitor. Very interesting discussion on these capacitors. All right, testing. Well, it's going a little faster than 1,000 microfarads did, but it's still pretty slow. Of course, this could also be a leaky capacitor. It's hard to tell whether you're looking at a good one or a bad one when you got one that's old. But you can see it beginning to dim. Let me get a mica that I've pulled out. It's probably not from this. This is a mica that's used in oscillator circuits. It says there's a brown white and green. I think this one is a 1500 or 1900 picofarad. So we'll just put this in here. I think it's connected. It's not. All right. So there it is. Let's put it in mica. Okay. There we go. Boom. That fast. So it's a good capacitor after 70 years. Okay. But that isn't always the case. But you find that micas that are used as signal passing, sometimes they seem to be stressed more than these oscillator capacitors. And you find yourself having to replace them. Let's see if I think I've kind of thrown away all the ones that are good. Okay, so we'll get back into this and I'll give you another update later today. Good morning. I found one of the problems with this thing not ohming out is this S-meter control, zeroing control is a 200 ohm rheostat, and it had two discontinuities or two points of open inside the track. You just peel back these little tabs carefully with one of these, and then the shield comes out. It was in here, there was a small discontinuity, and I just put the soldering iron right there and soldered just enough solder to reconnect both sides. I'm a little bit out of this camera. So I put the discontinuity was right about here, and I would just laid the soldering iron on top and heated just a little bit of solder to make continuity on both sides. Here it was a little bit, it mattered a whole lot less, and I wanted to make sure that was a good connection, so I made a whole solder ball there. But now this has continuity all the way through. Now, I wouldn't put a guarantee on this, but it got it working. And so, especially in the range that it's supposed to be. And the most important thing is that from here to here, there's 200 ohms. So it's back, and we'll put this back in and continue on. So I have finished up with the S-meter adjust, phono connection, and this 6BA6, which is after all of the IFs before you go into the output transform. So now I'm into testing and looking at V4, which is before all of the IFs, and a mixer, I think, or a converter of some sort. And these are ceramic capacitors. They shouldn't be a problem after 70 years. They're low tolerance, commodity, RF bypass capacitors, and there's no issue with leakage after all these years. So I'm going to leave it in. There's no point in taking it out unless you have to. It's just an RF bypass anyway. So that's what it takes to figure those out. That was actually on the mica setting. try it again. Yeah, very quickly. Okay, so we're continuing on from here. We'll be doing this tube, and then we'll start marching up these tubes. And then we'll see what's next. I'm down to one tube to go. And I'm out of energy, so that's all. That's it for the day. But the RF amplifier tube, there's AVC and another resistor to jack. The leakage on this capacitor and that capacitor, and we will have been through everything. I went through all of the resistors in the RF section. Did not pull this thing out. I didn't need to, and I was able to get in and clean the switches pretty good. Probably not as good as if I took it all apart, but good enough. And what else? Another difference between a Mark I and a Mark 1B is this is a 200 ohm S-meter adjust potentiometer with a 56 ohm bias resistor, and everything else in later versions it's all you can see here, it's 270 ohms from the bias and 500 ohms on the potentiometer. So a holdover, I think, from the SX-100. So all of this is wired in now, and we're getting close. Haven't done the power cord or anything like that yet, so that's still to be done, but we're getting there, and we'll continue this tomorrow. Well, I was wiring up the the transformer and all the input power cord and all that, and testing it out, and the switch was not was not working. So I pulled the switch back out. This plate here, it's okay that it's loose like that, but it's held in by another plate, and you can't see it. Maybe I can, yeah. There's this little notch, and when you turn it on, that notch rotates a cam. Oh, it's on the other side. Okay. I'm looking at the box. That's not the notch that we're talking about. It's on the other side. You can't see it. Oh yeah, maybe we can. It's just too hard. I'm contorting here like Twister. Okay, so this plate actually was distorted a little bit, and I had to flatten it out, and then the switch was locking up, and now the switch is working. But it's a delicate switch, and you can take it apart. There's screws here and here. Do it on a table where you'll catch all the parts, and you can clean it real good in here, and also make sure everything's straight and true. More than likely, this thing, again, got some weight on it. This is the edge of the receiver right here, so this is not the right knob, but you put all that weight on the edge of a knob like that, and you're going to have, a distorted switch. So you just never put the weight of the radio on any of the knobs or switches. You just have to handle it carefully. It's really heavy, but somehow in the past somewhere it probably got damaged a little bit, but now it's back to operating good and switching on and off like it's supposed to. Well, I'm kind of all wrapped up for this weekend and a Monday before I go to my father's house. Put this down. That's what came out of it. It's pretty much equivalent to doing an SX-100. Pretty complex machine. Takes a lot of time and I go slow. And I still have a bunch of coil resistances and inductances to record. We're going to do some more cleaning up on the underside here and that sort of thing before just straightening up and checking every solder connection that's refreshed. If there's no cold solder, there's everything's good and solid on every connection. There's no shorts. You spend the more time you spend at that, the less time you'll spend trying to find it later. And let's see, so it's pretty much ready to have the top side stuff put on. That will do this coming week, and but it's coming along and getting better by the minute. And yes, power switch works. Yes, like it should. And these others are not tightened in yet. So we'll have to do some resistance checking when we get the rest of this on here. We got the power cord in place, and then yes, inside here is more electronics that need to be serviced. This crystal box is easy to service. We've got the 3 leads coming out here. One is a signal lead. One is the my words just don't come to me sometimes. One is B plus and the other one is a filament. And you've got the numbers right here, very clear. We'll check out these resistors. They're probably okay. They don't see a lot of stress. But that goes in right here, and that'll go on top. Then we'll just start building it up from there. But we got to get inside this box. There's not a lot of electronics inside there, but there's enough to make it interesting. So we'll be doing that later on. Do appreciate the new subscribers and folks watching these videos. Just trying to add to the knowledge base. One thing is, this young man, I guess, he hadn't told me his age, David, on the Hallicrafters site, has redrawn the Mark 1B schematic. And I've got that, and I'm actually going to use that to validate his schematic, as well as to check my work and make sure I've got everything wired up correctly. I did that for the SX-99. That's how you learn these receivers, is complex receivers, is just sit down and this is connected to that and what does it do and so forth. You spend the time doing that, and then you know just about everything you need to know to service and refurbish these things. So I'll be seeing you next week. This is Hallicrafters Rehab. I'm Albert. Blessings to all, and thanks for watching.